Hi, this is Mrs. Applegarth again. We are going to talk about lesson 5.7 and 5.8 in this video. 5.7 is where you want to be in your savings account. Our lesson objective is to calculate the interest for daily compounding. It's right here. If you can get an account that'll compound interest for you daily, you have a good account because you are making money every day versus making money every period or every quarter or semi-yearly. If you can get it to compound every day, that is great. So daily compounding is the more often banks compound interest, the more potential you have to earn more interest. Many banks offer savings accounts with daily compounding. When they compound interest daily, it is computed each day and added to the account balance. The account will earn interest from day to day, from the day of the deposit to the day of withdrawal. You can use a table, which will be nice, to calculate the amount and the interest for daily compounding. We use these formulas in the previous section. So remember, the amount in our account is our original principal times the amount we find for interest for $1. And our compound interest amount is what we have in our account minus what we originally put in. And if you're adding it, if you're adding to the principal each time, you just have to calculate how much you've turned in completely. Right? If you need to pause the video to write these formulas down, go ahead and do so. Otherwise, we'll move on to example 1. Okay, so suppose we deposit $8,000 in an account. We get 5.5% interest compounded daily. How much interest will we get in 31 days? So we have to, we have the right chart where $1 at 5.5% interest. Daily, remember, is 365 days in a year. So we're going $31 days. Okay, now that I have the right table, so we look up our day 31, which is right here, and we see that it is 1.00468. So that's from the table. So then we go and in step 2, we take our original principal and multiply it by our amount from the table. So when we do that, we get $8,037.44. So after 31 days, we've already made, so do the subtraction, $8,037.44 minus the original $8,000 we put in. So that means we've made $37.44 just for having our money in that account for 31 days. So not too bad. Okay, so let's do these practice problems together. So I'm going to do number 1 below. So number 1, Ramona Odin deposited $6,000 at 5.5% interest compounded daily. So the amount in our account is going to be equal to that $6,000 times the number from the chart. So we have to look back and figure out what's our number for 25 days. So that is back here on this chart. We look at 25 days is right here. So it's 1.00377. So in here we go 1.00377. So the amount in our account after that 25 days is, let's grab the calculator, 6,000 times 1.00377. So it's $6,022.60. 62 cents. And then the amount of interest is equal to $6,000 minus, oops, it's backwards, sorry. It's the $6,022.62 minus the $6,000, which is equal to, I don't even need a calculator, $22.62. All right, let's do that for number 2. So our buddy Chuck deposited $6,000 and he let it sit for 31 days. So that's the 1.00468. So we're going to do this very same thing. So it's, I have forgot, I saw a squirrel. 1.00468. 468. We're going to do that calculation. 6,000 times 1.00468. And that's $6,028.08. And then the amount, so this was the amount in our account. And then our interest is that amount minus our original 6,000 that we put in. So the I don't even need a calculator for that. Easy peasy, $28.08. All right. Hopefully that makes sense to you guys. All right, last bit of our lesson here in Chapter 8. This is where the money happens. So lesson 5.8 is about annuities. So you're going to compute the future value of an ordinary annuity and an annuity due. So investing in annuities. Financial advisors recommend that their clients make regular deposits in a savings plan, such as an individual retirement account or an IRA. An account into which someone deposits an equal amount of money at equal periods or equal intervals of time is an annuity. So it's a little bit, so the reason it gets to be annuity is because you are adding, so not only are you getting interest, but you're also depositing money, more money into the account each period. There are 2 categories of annuities. Number 1 is an ordinary annuity. It occurs when equal deposits are made at the end of each interest period. And the other type of annuity is an annuity due. It occurs when you make regular deposits at the beginning of the interest period. The money immediately starts earning interest because it is deposited at the beginning of the interest period. The future value of an annuity is the amount of money in the annuity account at the end of a specific period of time. To compute the future value of an ordinary annuity, follow the steps in example 1 using this formula. Please write down this formula. The future value is equal to the amount of the deposit times the future value of $1. This is the table amount. So if you guys could please write the word table in parentheses right here. So that will remind you to find the future value of $1 in the table. To compute the total interest, use this formula. Your total interest is whatever your future value is minus the total of all your deposits. So that means you have to add all of the deposits up because you're adding a little bit of an amount each time. So add all of your deposits up and then subtract it from your future value, and that's how much you make in interest. The other money is the amount that you've already earned and put in. All right, let's see how this works with our example problem. So we have our buddy Phil. He deposits $500 in an ordinary annuity at the end of each quarter. Remember, there are 4 quarters in each year. The account earns 6% interest compounded quarterly. Okay, that makes sense. What is the future value of the account in 2 years? How much interest has it earned? So step number 1 is to find the total number of periods. So that's what you're always going to want to do, is figure out how many times are you going to compound your interest. So we go 2 years, and there are 4 quarters in 2 years. So we're going to compound this amount a total of 8 times. So the next thing we need to do is find the interest rate per period. So find the interest rate per quarter. So what we do is we take that annual interest rate and we divide it by the number of periods per year. And when we talk quarters, quarters are 4. That's the wonkiest looking 4 I've ever made. So in your calculator, we go 6 divided by 4. And because we're just keeping stuff in percents, we do it straight up. 6 divided by the 4 quarters. And we keep it at 1.5%. We don't convert this into its decimal form, because we're going to look at the table from A12, and we're going to use the information, the 1.5% and the 8 periods, to find our table amount. So I believe if we this up. So here, if we look at this table here, let me blow it up for you just a little bit more. So we have the 1.5%. Which is here. And remember, we're going 8 periods. So from the 1.5% and 8 periods, we see that the amount for $1 for 8 times compounded is 1.12649. Okay, pull that up, and that's where they get, oops, that is not the right chart, so hold on. Let me get the right chart. All right, so I found the correct chart for you guys. Thank you for your patience. So at the 1.5% interest for 8 periods, so 8 quarters, our amount is 8.43284. So we did all this work, step 1 and step 2, so that we could find the number from the chart. So once we have the number from the chart, we take our original deposit amount, multiply it by the number from the chart, and we find out that after 2 years or 8 quarters, we'll have $4,216.42 in our account. Pretty cool for $500 a month. So then if we want to find out how much interest we have, we take our $4,216.42. We have made 8 deposits of $500. So we have to do that little calculation, and we go, oh yeah, 8 times 5 is 440, and we put the 2 zeros from the 500 on there. So we go, oh, we've put in $4,000. So how much interest did we earn? So we subtract 4216.42 minus 4,000, and we get $216.42 just in interest. And remember that is over the course of 2 years. That account made $200 for us, which is great. It's a pretty good income. All right, you guys are now ready to move on to practicing these skills from Chapter 5.